Today we are solving systems of equations that have three variables, so an x, a y, and a z. So our ordered pair is now going to become an ordered triple. So x, y, z, remember it's going in alphabetical order. Okay, three types of solutions that we could have. We can visualize these as planes, so we want to figure out, do these planes intersect? So this is most common, one solution, where we will get an x, y, z ordered pair, and it is our ordered triple, and it's where the three planes intersect at a point. If it comes out to infinitely many, so we get a true statement, it's because the planes intersect at a line. All right, all three are intersecting there. If we get no solution, it's because the three planes do not intersect at the same point or line. So maybe the three planes are parallel. Maybe two planes are parallel and one's a transversal, or each of them intersects one other plane. Okay, so we have steps. Step one, eliminate one of the variables using the same steps learned in last lesson. We're going to do this twice. Solve the two new equations, and we're going to substitute them. So really, we want to go in and just kind of run through one. So I'm going to start this one out and tell you this time you must eliminate z. We're tackling z first. So when I do this, I'm going to call this equation 1, 2, and 3. My goal is to eliminate z. So if I take a look, let's first take equation, if I do equation 2 and 3 over here, right, equation 2 and equation 3. Equation 2 says 2x minus 3y plus 6z equals 28. And equation 3 is negative 1x plus 2y minus 6z equals negative 26. Then I will go ahead and add them. If I add them right now, my z's are opposites, so they will cancel. That is the goal. And it's going to create a new equation, equation A. So now I'm going to go ahead and add. 2 plus negative 1 is positive 1x. Negative 3 plus 2y is negative 1y. Our z's cancel, equals 28 plus negative 26 is 2. Now, hang on to that. We are going to end up putting it into this place in a moment. Now, we have to do this again. We need we need to pick two different equations from our originals, 1, 2, or 3, over here, and goal also to eliminate z. So this time, I can't pick 2 and 3 or 3 and 2, but I can pick 1 and 3 or 1 and 2. If I picked 1 and 2, what would I need to do? Would they cancel out right now? So I'm just ignoring 3. How would I get these to cancel? Well, I could get them into negative and positive 30. How would I do that? Let's take our first equation and let's multiply it by 6. Take equation 2, let's multiply it by 5. So equation 1, multiply everything by 6. So this is negative 30x plus 30y minus 30z equals negative 150. Equation 2, we're multiplying everything by 5. So this is 10x minus 15y plus 30z equals 140. Now I'm going to go ahead and add these, just like we would do if it was just an x and a y. When I add them, negative 30 plus 10 is negative 20x. 30 plus negative 15 is positive 15y. Negative 30 plus 30 is 0 equals negative 150 plus 140 is negative 10. I'm going to call this equation B. So B is going to go in here for me. This is just a graphic organizer. This is not something that you have to use every time. For our first example, it could be helpful to kind of organize our work for us. All right, so I have this equation A and B. Now, my next goal is to cancel out either the x or the y. So this is step 2. Solve the new 2 variable systems for both of the variables. So how could I get one of these to cancel? Well, if I took my top equation and I multiplied it by 20, that would allow me to cancel out my x's. So let's do that. 20 times 1x is 20x. 20 times negative 1y is negative 20y equals, don't forget this too, 40. I'm just going to rewrite down my equation B. And now I'm going to add these. Negative 20 plus 20 is 0. Those cancel. Negative 20 plus 15 is negative 5. 40 plus negative 10 is 30. Divide by negative 5. Y equals negative 6. That is one part of our answer. Remember, our ordered pair is x, then y, then z. Our y value is negative 6. All right, so now we need to figure out what x is. If we know y is negative 6, we can plug that into one of these equations. So let's go ahead and take this negative 6 and plug it in here. So 1x minus 1 times y, which is negative 6, equals 2. I want to plug it into equation either A or B because those ones only have 2 variables. So I have 1x, negative 1 times negative 6 is plus 6, equals 2, minus 6 on both sides, x equals negative 4. All right, we need one more part of our answer. Now step 3 says substitute the values found in step 2 into the original equation. So we're going to take x is 4, y is negative 6, and we're going to plug those into one of our equations, either 1, 2, or 3. We get to choose. It does not matter which one you choose. I will go ahead and pick equation 3. So I'm going to go over on this right-hand side. First, I'm going to just rewrite the equation. So I have it right there. And I'm going to substitute in. I know that x is negative 4. So I have negative and then negative 4. Plus 2 times y, which is negative 6, minus 6z equals negative 26. Order of operations, negative 1 times negative 4 is 4. 2 times negative 6 is negative 12, minus 6z equals negative 26. 4 minus 12 is negative 8, minus 6z equals negative 26. Add 8 to both sides. Divide by negative 6. So z is 3. So our planes intersect at this 3-dimensional ordered triple, negative 4, negative 6, 3. Now that's a lot to follow. You got to follow each of your steps, take your time, and keep your work organized. So maybe you want to add this little note. What did we do with this negative 6 here? We plugged into equation A. And then we took this and we said plug both x and y into an original equation. Let's try another. So I'm going to number these, equation 1, 2, 3. All right, so we get to decide what we want to eliminate, x, y, or z. Whatever we pick, we have to stick with. So I'm noticing right now that all of these x values are all positive. Okay. The y values, some are negative, some are positive. That's nice. And I have a 1 y. That could be helpful. And my z's, all are positive and none are the same number, 3, 4, 5. So my goal, I'm going to go ahead and say, let's eliminate for y. So let's take these two equations. So eliminating for y, I'm going to take equation 1 and 3 first. Now those will not cancel out. So equation 1, so I'm focusing on these y values. Can I make this 1y into a -2, the opposite of this one? Yeah. Equation 1 gets to stay the same. 4x plus 2y plus 3z equals 1. Equation 2, I'm going to multiply that by 2 in order to get my y value into -2. So 12x minus 2y plus 8z equals -2. Don't forget to multiply every term. Add these. This is going to give us equation A. And you don't have to label it A. That just sometimes helps me stay a little bit more organized. 4 plus 12 is 16. X. Y's cancel. 3 plus 8 is 11. Z equals. Now my z's look like 2's, so that's why I put a little line through them. 1 plus -2 is -1. All right, we'll come back to A. Now, I need to take two new equations. I can't use 1 and 3 again, but I could use 1 and 2 or 2 and 3. Let's use 2 and 3. So this time I'm looking at 2 and 3. If I were to add them right now, nothing would cancel. But could I get this -1y to become the opposite of -3y? To get to become a 3? Sure. I'd have to multiply by -3. So equation 2 will stay as is. 2x minus 3y plus 5z equals -14. Equation 3, we're going to multiply by a -3. So this becomes -18x plus 3y minus 12z equals +3. Let's add them. So I get -16x cancel minus 7z equals -11. That would be what I might call equation B. Now I take equation A and B. I'm going to work in the middle here with those. Equation A and B. 16x plus 11z equals -1. -16x minus 7z equals -11. All right. Now if I add these two equations, x's are going to cancel. This is beautiful. X's cancel out right away. I do not have to manipulate these. 11 plus -7, 4z. -1 plus -11 is -12. Divide by 4, so z is -3. Plug into A or B. Does not matter which one you plug it into. I'll plug it into B since I'm right there. -16x minus 7 times -3 equals -11. Subtract 21. Divide by -16. Okay. Now we're going to take both of these, plug into one of the original equations. I will pick equation 1. So equation 1 says 4x plus 2y plus 3z equals 1. X is 2, so 4 times 2 plus 2y plus 3 times z. Z is -3. So this is 8 plus 2y minus 9 equals 1. 8 minus 9 is -1. Add 1 on both sides. Divide by 2. y equals 1. Okay, my final answer should be an ordered pair, x, y, z. So I have x, 2, y, 1, z, -3. Okay, try the next couple on your own.